For our next example here, we're going to come up with a linearization of f of x equals sine x at x equals 0, and then we'll look at what that tells us. Let's remember our linearization formula. L of x equals f of a plus f prime of a times x minus a. And in our case here, our a value is 0. Notice how a problem could be worded either way. They could say find this linearization at a equals 0, or they could say at x equals 0. It's still referring to the same thing there. So might as well put in an a there, a equals 0. I could make that as a note for you, though, since you might see it with an x. Okay. So our linearization here, L of x is going to be f of 0 plus f prime of 0 times x minus 0. Okay. Now we'll find some values here that we're going to need. F of 0 is the sine of 0, which is 0. Lots of zeros here. Our derivative of sine is cosine. And so f prime of 0 is cosine of 0, which is 1. Okay, so we'll go put those in. L of x equals f of 0, which is 0, plus f prime of 0, that's 1, times, well, x minus 0, which is just x. Okay, so it turns out to be a really simple line here. L of x equals x. That is our linearization. Okay, so this linearization, remember, this also gives us the tangent line, or it is looking at the tangent line to sine x at x equals 0. Okay. And so this linearization, if you'll remember how we've been using these will approximate the behavior of our function near that value. So this approximates the behavior of f of x near x equals 0. Okay, so f of x is approximately equal to L of x. That's what the idea is there. And so what that tells us is that f of x is sine x, and L of x, the approximation, is just x. So sine x is approximately equal to x near x equals 0. Okay, and this is actually a result that we have seen before. This is the nice result from many sections ago. Let's see, I think that is section 2.4 on one-sided limits. The nice result there was that the limit as theta approached 0 of sine theta over theta, that was equal to 1. And so that told us that the sine of an angle and an angle itself, the angle value, were about equal to each other when the angle was really small. And so this result with the linearization is actually just saying the exact same thing, but in a different way. We're calling our angle x. We've used a linearization here, but the sine of that small angle is basically equal to the value of the angle itself, as long as the angle is really small. So it's still a nice result.